Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue talking about my current project of coding the combat system for a viewer's game. In particular, when we ended the last video, I was up to the special bonuses that the player character or their companions get when they score a very high attack roll, which is what this game calls a long success, and it's the equivalent to what other games might call a critical hit or a critical success. A very high number, specifically a roll of 10 or more. And I talked about what the effects are going to be in the last video, but I hadn't coded any of them. Well, I've coded 2 out of the 4, and that's what I'm going to show you today. So there won't be any new variables that we need to look at, but there will be an addition to an existing variable. An existing array has now had another slot added to it, as we'll see. So let's start by looking at PC side attacks. And I've slightly rearranged the code. I've shown you this page before, but I have slightly rearranged the code. The first thing I will say is that we find the attacker's persona, which is the equivalent of character class, and we store it in $y. And the way we do that is we look at ini underscore who. That is the variable that keeps track of who currently has the initiative, whose go is it, who's acting, and in this case, who's attacking. If it equals 0, that means that it is the player character, and we set y to have the value of the variable $per, because that's the player character's persona. If it's anything else, which means it'll be a positive number, instead we look at $com, $ini underscore who 1, because that's where we keep the persona, i.e. character class, of a companion. You'll notice that we also have this text here because we're starting the message that is going to be printed out here. We might as well start it here because we have to print something different depending on whether we're talking about the player character or the companion. This is the beginning of the message that's something like companion 1 rolls a 4 and a 3 plus such and such for their strong value minus such and such for the enemy's sneaky value for a total of this, and then it tells you whether that's a failure or a success or what. So we have the attacker's persona stored in Y. The rest of this code that I'm scrolling past is the same. Some of the variables I've slightly rearranged the variables. In particular, this wasn't. I don't think this was Y3 last time. Maybe I'm wrong about that. I don't remember. I have changed the names of it. I have changed what's stored where a little bit, but anyway, other than that, it's basically the same. So here we have some new code. If $y3 is greater than 9, well, this is, if $y3 is greater than $9, $y3 is the variable which has the final result of this roll and add and subtract process. And anything that's greater than 9, i.e. anything that's 10 or more, is a long success. And so this code here, going down to there, is the bonuses for long successes. And as the note says here, they are different for different personas. I've shown you this list before. I've put numbers next to them. Those numbers just mean what the value of Y will be for that particular persona, because this isn't in the order that they're in the array. So a value of 1 means a warrior, 2 means a scientist, 3 means a scoundrel, 4 means an influencer. I have done the scientist and the scoundrel. I should have put a done there, I suppose, to be consistent. But I put it next to the scientist, but not the scoundrel. So, but it doesn't matter because I'm planning to delete this comment once I've done everything. This is just a note to myself of a sort of half-completed task, I suppose. But yeah, I've done the scientist and the scoundrel, so let's have a look at that. So in this, if y3 is greater than 9, We have a branching based on Y, which is, again, the persona that we're talking about. If Y is equal to 1, haven't done that yet. If Y equals 2, we've got some code there for scientists. If Y equals 3, we've got some code for scoundrels. And if Y equals 4, haven't done that yet. So the scientist is the easiest one. It's the simplest one. The scientist adds their smart score of 3 to the damage. So all we do is we set Y2 plus equals 3. In other words, we add 3 to Y2. And then we have a little message here that goes in. This becomes part of the message that the player will get, which is something like, well, it does 7 damage for the attack, plus something or other, plus their smart score of 3 for the long success. All of these bonuses are going to be 3, because the concept is that you add the score that is your class's or persona's specialty, and that's always the one that has a value of 3. So in the case of scientists, they add their smart score of 3 to the damage. So we just increase this variable, Y2. I'm not sure that was the name of the variable that was keeping track of the damage before, because as I say, I slightly changed the names of some of these variables, swapped some of them around as I was coding this. But anyway, that's what the damage is now. So that's fairly straightforward because it happens straight away, and it just increases damage. The scoundrels bonus is a little bit more complicated. It requires some code on several different passages or pages other than this one. It says, as it says here, the scoundrel's sneaky score, that should be a possessive apostrophe there, sorry about that. The scoundrel's sneaky score penalises this enemy's next attack roll. So that's a thing that's not going to happen straight away. It's not going to happen until and unless this enemy makes another attack roll, of course. So we have to keep track of it somehow. And what we do is we add it to enemy Z5. Now, enemy, we've talked a lot about this variable, this array. It is the array that keeps track of the details of the enemies. That's what NME is sort of an abbreviation for. Z is simply the target of the attack, Z is simply the target of the attack. And then we store it in slot 5. Now, we haven't had a slot 5 in NME before. This is the addition that we made to this variable. So let's get into initialize and look at the listing for NME. We've seen all these before. It's the type, the hit point, the current hit points, their position, whether they're flying or not. Well, now we've got a new one, which is it stores any penalty to this enemy's next attack roll due to suffering a long success at the hands of a scoundrel. And that value always starts at 0, of course. And it is increased by 3. It's not set to 3 because theoretically you could get 2 scoundrels damage the same enemy in the same turn, and so the penalty would be 6. It'd be very unlikely, and often if 2 scoundrels hit the same enemy, that enemy might die anyway, so it doesn't really matter what their penalties are. But it technically could happen. And so instead of setting it to 3, we set it to its current value plus 3. In other words, we use plus equals 3. So having done that, we need to make it happen. And that is going to happen because it's a penalty when the enemy attacks. It's going to be down here when the enemy strikes. And specifically, it's down... Where is it? Oh, yes, here we go. We are doing basically the same things that we do for the player character or a companion. We roll dice, add their strong or their sneaky score, subtract the target's sneaky score, and now there's a special addition. If enemy ini underscore who5 is greater than 0, we print minus, usually it'll be 3, minus 3 for scoundrel's long success penalty. Then we subtract that penalty from x2, which is the current, which is the value of the roll, the overall or the value of the roll plus bonuses and penalties. And then we set that slot in enemy to 0 because it's a one-off penalty. You only do it once. It's not every time you attack. It's once you do it, it's you've sort of paid the penalty. That enemy has sort of paid the penalty, and it's reset to 0. So another thing that might happen is that enemy might die before it discharges that penalty, and we don't want the next monster in that slot in the next attack that we have in the game, in the next combat that we have in the game. We don't want them to have that penalty. It doesn't carry over to that new monster, of course. So when the player has won, when we get to a situation where the player has won the combat, one of the things we're going to need to do is reset the value of every slot in this part of the array to 0. So we do this with a for loop. We just have a for loop that goes from 1 to enemy underscore max, which is the maximum number of enemies. So we by using that variable, we're sure to cover all the slots that we could possibly need. We might cover more than we need, but we won't ever cover less than we need or fewer than we need. And for every run through, we set enemy. You know what? I think I've done 2. There we go. Sorry about that. I just noticed a mistake. We set enemy Z5 to 0. I'll fix that in the version that I upload to itch.io. I'll also fix that problem where I didn't put the done in one of the parts of my notes in the version that I upload. So sorry about that. We set enemy Z5 to 0. Of course, there's more that's going to have to happen with the player winning. This isn't going to be the complete code, but one of the things we're going to have to do is reset this this part of the array, just so we don't accidentally get those values carrying over in a way that they shouldn't. And that is how we do those 2 bonuses. We still have 2 to go, and of course that's what I'll be looking at in my next video. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.